I'm Fred Dick, and I'm based in the Birkbeck UCL Center for Neuroimaging here in experimental psychology at UCL. I'm most interested in how it is that we can do what I'm doing right now, which is speak a language, or for instance, play a musical instrument, or play professional sports. How is it that humans who basically look and whose brain looks very much like other primates are able to acquire these abilities that seem so qualitatively different from other primates? This is especially interesting because when we look at our brain, it looks very much like other primate brains. So the two questions that my lab asks are, what are the mechanisms that allow us to acquire these complex skills? And how do they overlay over the basic primate plan that clearly still governs our human brains? And how can we compare the perhaps quantitative shifts between our brains and those of other primates to understand the kinds of changes that may be useful for acquiring these complex skills? Language is intrinsically interesting and obviously defines us as being humans. Without language and without being able to apply all of these other complex skills, like playing a violin or playing sports, we really could not get along in even very simple human societies. So understanding that is a really worthwhile intellectual goal, I think. But of course, there are a lot of other things that are more practical that this research addresses. For instance, how is it that we can make people better at learning language, particularly if they're struggling, for instance, in school, or after they've had brain injury? How can we use what we know about the brain to really hone in on the most important parts of learning after brain damage? One of the big questions in neuroscience is how particular regions of the brain become more sensitive to a very specific class of, for instance, sounds like speech, or things that we see like faces. So many people have shown that parts of the superior temporal gyrus and superior temporal sulcus, right here in the brain, are particularly active when we listen to spoken language as opposed to, for instance, music. So how does this happen, and what does this mean about the way that the brain shapes itself to work? What we found is that at least some of this neural specialization is actually due to the way that you interact with the world, and also with the kinds of sounds that you yourself produce. So for instance, if we ask violinists to listen to violin playing as well as speech, we actually see that many regions that in most people would be very speech selective, so they would only show firing really for listening to speech, that violinists actually recruit a number of those same regions to equivalent levels when they listen to violin. So this suggests that much of the specialization that we see in the brain may actually be due to the way that we interact with what we hear or what we see, and how we're actually able to reproduce or represent those sounds or sights in the world.